Hi all, in this lab, let us understand how to implement decoupled architecture pattern called orchestration and coordination. Okay, let's get started. So we have one step function and where we have multiple states. So one of the state is basically payment charge, then account credit and payment refund. Okay, there are multiple lambda functions for each of this processing. Then some of the states are basically updating into the DynamoDB database. And if one of the states fails, then we have a notification mechanism. So we will send a message to SNS topic and through which the subscribers will get the message. So here we have two subscribers and both of them are SQS queue. So on success and on failure. Okay. Now here what we have represented is various AWS services and their interaction. Okay. But in the actual step function, the flow is completely different based upon the business logic. Okay. Now let us go to the source code and see how to implement a typical coordination use case using the step function and using multiple AWS services. Okay, let's get started. Hi all, in this lab, let us understand how to implement orchestration and coordination integration pattern between the microservices. This is very popular pattern where a step function is used. Okay, so in this case what we're going to do is we will trigger one step function to do some payment processing. Okay, and if it fails then we will also do the error handling and we'll also do the retry mechanism. Okay, now let's go to the source code and see how it's implemented. Okay, now let us start with the lambdas first. Okay, so we have three lambda functions in this example. The first one is a payment charge. So first we are going to charge the customer based upon the ride that he has taken. Okay, so this is a simple Python based function to do the payment processing. Okay, and then there is a account credit. So creating the account to the customer account. Okay, this is one more function. And the third one is payment refund. In case if the previous any one of the two previous transaction fails, then we have to refund back to the customer account. Okay, now this is the set of lambdas. Now then we will also look into SNS. Okay, if any one of the state machine steps fails, then we will trigger a message. We will publish a message to SNS topic, and there are two queues, SQS queues attached to the SNS topic as a subscriber, right? So the first one is basically the successful queue, and the second one is a failure queue. So if the transaction is successful, we'll be sending a message to this queue, which is the first one based upon this message attribute criteria. Okay, and the second one is a failed criteria, right? Is successful is equal to false. So whenever a message comes to SNS, whenever a message is published based on the successful or failure criteria, that message will be sent to the respective destination. Okay. Now let us go back to the step function. Before that, let us do DynamoDB also. So we will be storing the state information, the fair information into the DynamoDB table as well. Okay. Now the crux of the code is in the state function. So this is where we will be implementing a multi-state state function. Okay. So initially we will start with the register fare, and that is basically updating an item into the DynamoDB, and then there's a retry logic, and there is a catch errors logic also. Then we'll be having charge fare lambda function. Then there's a retry logic and catch error handling. Then the credit to customer account one more lambda with the corresponding retry and the catch error handling. Then if it is successful, then we will set the fair statement status completed. So this is updating the DynamoDB database. Then if it is a failure, then again we have to update the DynamoDB database that the transaction is failed. Okay. And there is a notify success, there is a notify failures. In both cases, we will be sending a message to SNS topic, which will be sending the message to the respective SQS queues based upon the message criteria. Okay. And there's a refund function also. In case if the transaction fails, we have to refund the money back to the customer account. So there's one more lambda which is getting triggered with this functionality. So there is a notify failure also. So again, there is SNS topic. So this is a very simple state machine that we have to deploy, and there is a corresponding IAM permission that we are providing because step function has to talk to DynamoDB and also invoke Lambda functions. Okay. Now let's go ahead and deploy the source code using the Terraform scripts. Okay. Terraform init. So I've done that already. Terraform plan, which also is done. I'll just rerun for any changes. Then I will do Terraform auto apply. Okay. So Terraform auto apply is completed. This is the output. Now let us go to the AWS console and look at the resources. Okay. So this is my step function console. So I have one state machine defined. And if I go to the definition of the state machine, so this looks like this. Okay. So we start here. Then register fare is where we update DynamoDB, and then we'll have a charge fare lambda function. Then there is a credit customer account lambda function, and there is a refund fare. So if in case if this fails, so like that, there are multiple states within this state function. Okay. Now if you go to SNS topic, so we have one topic created, and there are two subscribers, and both of them are SQs. And for example, if you look at the criteria for the first one, I have is accessible is equal to true, which is a message attribute. So if the incoming message contains this, so this particular queue gets the message, and the other one is this. So let us look at the SNS topic. Here we have two subscriptions. Okay, first one is basically an SQS queue, which is a successful transaction queue. The second one is a failed transaction queue. So for the first one, the message attributes is successful is equal to true. Okay, and for the second one, it is basically the other way. It is false. Okay, now let us go to SQS queue. Okay, so we have two queues, and there are some messages available. We will check that. And there are three lambda functions, right? Payment charge, payment refund, and payment account credit. Basically, these are the simple Python based functions. So what we will do is, let us trigger the execution of the pipeline. So we will create one test event. Okay, so with the sample of event.json file. Okay, now let us get the step function ARN using the Terraform output variable. Then let us submit this. I'll just change the name of this to a different value. So step function execution done, and this is the output. Now let us go to the AWS console and look at the state of the execution. Okay. So this is a test for that we have run. So it is successful. Okay. All the stages are passing the different states. So you can just click on that. You can look at the input and output for each of the stage. Okay. Now what we will do is, let's introduce some errors. Okay. So let us first create one more JSON object, event1.json, and we will introduce some errors. So we will create this JSON file, and we will run this again. So here I will do test2 and provide uh, this JSON file which contains some error. Now if you go to the console again, look at the execution, you will see test2 is failed. Why? Because we introduced an error. So it is failing at the charge fare, which is expected. And when it fails, it is going to this particular state and updating the DynamoDB saying that the state is failed, and we are also notifying the subscribers. Okay, and this is the error state. So this is how we can simulate different paths, different flows within the state machine by sending the um, JSON file with the different values to trigger the exceptions. Okay, so with this, what we have demoed so far is how to implement orchestration and coordination across different components in a distributed environment.